Hey, awesome people. Welcome back to another fractions video. My name's Mr. C. Thanks for joining us. Make sure if you learn anything new, click the like and subscribe button. Join us as we continue making math understandable and challenging. This video today is going to be the 4th grade learning standard comparing two fractions with different denominators using the multiplication strategy practice problems video. Again, this is the 4th grade learning standard comparing two fractions with different denominators using the multiplication strategy practice problems video. If you are looking for the teaching video, it is in the description below. I bet if you missed that, it would be really important to watch. So check it out. Also, in the description, you will see all of our 4th grade fractions playlists. You will see our 3rd grade fractions playlist and our 2nd grade fractions playlist. Fractions has been awesome. We've spent a lot of time there. Make sure you check out those videos if you're not caught up. Let's focus today on comparing two fractions with different denominators using the multiplication strategy practice problems. Let's get started. Here we are with our very first problem. We are going to compare 7/10 and 1/2. Before we do so, make sure you have the correct mindset. Make sure you have a growth mindset. You are ready for a challenge. You're not going to give up. You're going to use your mistakes to help you get better. Just because you struggle doesn't mean you give up. You just don't know how to do it yet. Stick with it. So we're using the multiplication strategy to compare two fractions. And right now what we've got is 7/10 and 1/2. And feel free to pause me and try this one on your own and then join me. The first thing I notice is that our denominators are two different numbers. And that's going to make it a little bit of a challenge to compare them the way they currently are. So what I'm going to do is I'm going to see if we can find the LCD, better known as the least common denominator. And what we're looking to see is, do these two denominators have a number in common? And if they do, we're going to create some equivalent fractions and then compare them. So what I've done over here is I have listed out the denominators, 10 and 2. And what I want you to do is skip count. And again, I only skip count a couple of times. I can keep going and going if I want. I don't like to do a bunch of extra work, but if you do, go for it. I'm going to skip count by 2, 2, 4, 6, 8, 10, 12. Now, is there a number that both of these have in common? 10, 20, 30, 2, 4, 6, 8, 10, 12, so on and so forth. Do you see a number that they both have in common? Do they both have 10 in common? Well, I see a 10 here, and I see a 10 here. So there we are. We're in luck. Our very first number we listed, they have in common, which is awesome for us. So we're going to use this information now to create some equivalent fractions for our two fractions we already have. So what we're going to do is we're going to focus on the purple fraction first, 7/10. And our new denominator needs to be 10. So when we're making our equivalent fraction, our new denominator is 10. And you've got a cheat sheet here, or you can tell yourself 10 times what gives me 10. Cheat sheet tells me I skip count one time. 10 times 1 is 10. So there we go. We've got 10 times 1, that gives us 10. Now, if I multiply the denominator by 1, what am I supposed to do to the numerator? Well, whatever you do to the bottom, you do to the top. Whatever you do to the denominator, you do to the numerator, and vice versa. So if we multiply the denominator by 1, let's multiply the numerator by 1. I bet you already know what 7 times 1 is. Yeah, it's 7. So notice, did this fraction change? No, it didn't. Okay, it didn't. 7/10 is equal to 7/10. All right, so now let's focus on our pink-ish fraction. So we know our pink fraction here, 1/2. Our new fraction, our equivalent fraction, is going to have a denominator of 10. So use your cheat sheet or ask yourself, 2 times what will give you 10? Well, 2 times 5 gives me 10. My cheat sheet tells me 1, 2, 3, 4, 5. 2 times 5 is 10. Now, if I multiplied the denominator by 5, what do I need to do to the numerator? Psst, it's the same thing. Multiply it by the same thing. So, 1 times 5 equals 5. Now, we've been doing this for a little while now, comparing fractions. I'm going to put the symbols up here on the screen. Are you able to compare these two fractions now easily? Yeah, they're a lot easier to compare than 7/10 and 1/2 because the denominators are the same. When they're the same, all we got to do is look at the numerator. So, is 7/10 greater than 5/10? Is 7/10 less than 5/10? Or is 7/10 equal to 5/10? Well, if you take a look at the numerator, we know that 7 is greater than 5, so 7/10 is greater than 5/10. Are we done? No, we're not done. Remember, our original problem was asking us which one to compare these two fractions, 7/10 and 1/2. We are comparing these two fractions. We did all of this work here to make it easier to compare. Because when we just looked at our fractions to begin with, it was just kind of hard. Like, I couldn't just picture that. Sure, in my mind, I had a pretty good idea that 7/10 was greater. But what I did was I've proved that. Okay? Take a look at this problem. See where you may have made a mistake at. Rewatch us if you need to. And then try this next one with us. We're going to see if we can do it again. All right, stick with it. Let's try this next one. So in our next problem here, we've got 2/4 and 4/8. And feel free to go ahead and pause and try this one on your own and then join me. The first thing that I notice about these fractions is that the denominators are different. And again, in my head, you may get to the point where you can picture these two fractions and you're like, boom, Mr. C, I already know. I can compare these in my head. Sweet. Nice. That's awesome. Prove it to me. Okay, prove to me that you know what you're talking about. Okay, that's the big thing. I love them when people can do this type of stuff, but make sure you can prove it as well. All right, just like I prove it to you every problem we do, because I don't want you just to hear it from me. I want you to see it so you know I know what I'm talking about. So denominators aren't the same. So what we need to do is to find common denominators, the least common denominators. So our denominators were 4 and 8. I'm going to skip count by them. 4, 8, 12, and then for our blue fraction 8, 8, 16, 24. All right, do you see a number that they have in common? Do you see the least common number? The smallest number they have in common? What is it? It should be 8. 8 is the least common number they have in common. So let's make some equivalent fractions over here. That way we can compare our original two fractions. So our orange fraction is going to have a denominator of 8. That's what it told us over here on the left. And what we've got to figure out is what the numerator is. But before we figure out what the numerator is, how did 4 turn into 8? If I look at my cheat sheet, I skip counted 1, 2 times, or 4 times 2 equals 8. Okay? Now ask yourself, if you multiplied the denominator by 2, What should you do to the numerator? The same thing. Make sure you multiply the numerator by 2. 2 times 2 gives me 4. All right. So what we did here is our orange fractions are equivalent. 2/4 is equal to 4/8. What we did was we multiplied the numerator and the denominator by 2 and created an equivalent fraction. Now let's do something very similar on our blue fraction. Our denominator needs to be 8. Oh, this one's probably going to be a lot easier, I think. Take a look. You see what I'm seeing? How did 8 become 8? Oh, don't say 0. I know some of y'all said 0. All right, 8 times 0 is 0. We multiplied it by 1. 8 times 1 equals 8. Multiplied the numerator by the same thing. Multiply it by 1. 4 times 1 is 4. And again, we multiplied these by the same number. We multiplied it by 1. If you multiply anything by 1, you're going to get the same thing, right? So nothing's really changed here, okay? But what has changed for us is that our denominators are now the same, okay? The denominators are now the same, which is going to make it very easy for us to compare. So is 4/8 less than 4/8? Is 4/8 greater than 4/8? Or is 4/8 equal to 4/8? Which one is it? Well, look, ladies and gentlemen, denominators are the same, numerators are the same. These are equivalent fractions. But hold on. Our original problem was 2/4 and 4/8. We were comparing these two fractions. What did all of this work here tell us? All of this work here tells us that 2/4 is equal to 4/8. Do you see that? Do you see what we did? We originally couldn't compare these fractions easily because the denominators were the same. Once we made the denominators the same, it was so easy to compare them because all we had to do was look at the numerators. All right? Then we got our final answer. 2/4 is equal to 4/8. Okay, same thing. Pause it if you need to. Figure out, where are you making a mistake? What are you not understanding? What doesn't make sense? If you can find your mistake, you are on the right track. If not, stick with it. Join us for this next problem. Final problem I have for you today. We've got 2/3 and 2/5, and I'm going to run through this one. Feel free to pause me at any point. Try it on your own. But first thing I noticed was that the denominators are not the same. So because of that, it's going to make it a little bit hard for me just to look at them and compare. Okay? I'm going to create equivalent fractions for the green fraction and for the red fraction, but I'm going to make sure their denominators are the same. So first thing I'm doing is I'm going to skip count by the denominator of 3. 3, 6, 9, 12, 15, 18, and then I got the 5 over here from this denominator for the red orangish denominator. 5, 10, 15, and 20. So when you're looking at these numbers here, do you see one that they have in common? Well, let's look. 3, 6, 9, 12. Oh, I see one. 15. They both have 15 in common. That's great news for us. That means we can now do some work over here. So let's focus on this green fraction. Our green fraction is going to have a denominator of what? It's going to have a denominator of 15. Your job is to figure out how in the world did 3 turn into 15. Use your cheat sheet. How many times did we skip count? 1, 2, 3, 4, 5. Well, 3 times 5 equals 15. Now, I already know some of y'all are probably shouting this out. You know what I'm about to say. If we multiplied the denominator by 5, what do we do to the numerator? We do the same thing. Multiply the numerator times 5. 2 times 5 gives us 10. So right here, our green fractions are equivalent fractions. Now let's see what we can do with our reddish orange fraction. We are taking this 5 and creating an equivalent fraction that has a denominator of 15. So how did 5 turn into 15? Well, 5 times 3 gives me 15. Let's look at our cheat sheet. How many times did we skip count? 1, 2, 3. 5 times 3 equals 15. There we go. If I multiplied the denominator by 3, I need to do the same thing to the numerator. Multiply it by 3. 2 times 3 gives me 6. Okay. My green fractions are equivalent. My red fractions are equivalent. Take a look. The denominators are now the same. If the denominators are the same, that's going to make it really easy for me and you to compare this. Is 10/15 less than 6/15? Is 10/15 greater than 6/15? Or is 10/15 equal to 6/15? Which one is it? Well, 10 is bigger than 6, so 10/15 is greater than 6/15. Hold on, don't stop, don't give up. There's something we still need to do. Our original problem was 2/3 and 2/5, and we were comparing these two fractions. Let's make sure we finish up strong here. This is the original problem. 2/3 is greater than 2/5. Notice, it was harder to compare these two fractions when the denominators are different. Is it doable? Yes, you can know this in your head already and figure it all out, and that's awesome. But I want to make sure you have a strategy that, like this, that allows you to be able to prove your thinking. Because what we're going to be doing very soon is adding and subtracting fractions that have different denominators. And we're going to use this strategy, a strategy very similar to this, to figure that out. Okay? So, make sure you check out the teaching video. If you're still a little bit confused, check those out. It's in the description below. Rewatch this if you need to. Reach out to me on any of the social medias. Emails at the end. If there's anything that you need help with, something that doesn't make sense, I always love hearing back from people. Thanks for tuning into this video. Make sure, if you learned anything new, click the like and subscribe button. Join us as we continue making math understandable and challenging. That's all I have for you today, ladies and gentlemen. Mr. C, out.